Here's the graph of f of x. Sketch the graph of y plus 4. So probably what I would do first is I would take the time to move that 4 over. Personally, when I write things, if I have two sets of brackets, I find it visually very pleasing to make one set bigger than the other. It's really obvious then where one closes the other one and can help you just understand it better. But I can move that 4 over. There we go. Now labeling things. Can you see this will be inside, horizontal, stretch or compression? Stretch. The 1. Do you see it's already in factored form? So this is good. We can say this is going to be a horizontal translation. And the minus 4 will be a vertical translation. Personally, if I was doing this graph, I probably would use, I know they label 2 points. I like those 2 points better. I'm going to use 1, 1, and -1, -1. This graph also has an asymptote there and an asymptote there. So when doing this strategy where you do the arrows, we're also going to look at what happens to our asymptotes. So I'm going to write x equals 0 and y equals 0. I'm going to do the points first. So I'm going to draw these lines. And above the first line is where I do all my stretches. Do you see you only have the one stretch? So above this one, the only thing I need to write is x by, x's are liars, x by 2. We have 2 translations, so above the second arrow is where we do our translations. X's are liars, we're going to go 1 left and 4 down. So we can see where these points end up. X by 2, 2, 1, -2, 1. 1 left will be at 1 and -3. 4 down would be at -3 and -3. Oops. Did you see what I did? Something went wrong somewhere.
Yeah.
No.
I can't see you on negative.
I forgot a negative. Okay? This should have been a -1. Okay? Which would make this number different. I would like to say that I made that mistake on purpose for teaching purposes, but I have to admit, I made that mistake honestly. Okay? It wasn't, okay, I might have said this yesterday. When you're doing this mental math, it is so easy that you might start thinking about what you want to do next. That is very human nature. When we do something easy, we already start thinking of what we can do next because it's so easy. Okay? I've told you that you should always double check as you go. I did the mental math, and I can tell you this for certain, I was double checking my mental math the whole way through. But what did I have to do with the y values? I just had to copy them down. Copying them down is easier than mental math. And I didn't even check it, and I copied a number down wrong. Have you ever done that in a math class?
Right? It's exact same thing as you right here, so yeah.
It's super easy to do. You know, sometimes I've had students come in and they go, I don't know what I'm doing wrong with this question. And I sit with the student and we look at it over and over and over again and we spend 5 minutes checking everything. Everything is perfect. And then I say, did you write the question down right? And they're like, oh. So sometimes the easiest thing, which is just copying down the number, can be the place where we make our mistake. And that there are ways to check that. And you'll get good at checking. In fact, when we draw the graph, if your graph, like, you kind of get this this looks messed up feeling, it usually means you did something along that line. Something's wrong in my graph, I probably made a silly mistake. Okay? Next, we're going to look at our asymptotes. And with our asymptotes, we can actually draw a long arrow. And the reason we can draw a long arrow is because they both start at 0. Can you see that multiplying by anything is not going to affect it? So we can ignore the stretches and compressions because they're going to keep it at 0. The only thing that's going to change it is whether you move left, right, up, or down. And because I'm moving 1 to the left, this asymptote's going to be at x equals -1. And because I'm moving down, this asymptote is going to change to y equals -4. Now you're going to often see, although you could draw it on the same graph, I find for our brains, it's often easier to visualize if you draw it on a new graph. If I have a graph with asymptotes, I will always start with my asymptotes and labeling them. So x equals -1 and y equals -4. I should have a point at 1, -3. And I should have a point at -3, -5. And with the asymptotes there, we now have enough information to draw our graph. Question?
I heard you saying that our online course was due on Monday before I went to the bathroom. This is Friday. Is it on Friday or Monday?
It's on Monday. I didn't write it on here because I thought that the other class. But it's only fair because you didn't get the code. Sorry. I can't copy things very well. It's 2 copy mistakes in 2 days. Oh. Next, do you recognize the red graph from our colored papers? Our red graph is 1 over x. I'll write it in red. The red graph was 1 over x, and we just graphed in blue y equals we just graphed this in blue. Again, we're going to take some practice working with function notation and explicit notation, switching back and forth. This is the function notation. Basically what function notation says, if you have the basic function, which is 1 over x, anytime you have f of x, you're going to replace it with 1 over x. And anything that you have where the x is, replaces the x. Okay? That means in our situation, we are going to write, well, here I have f of something. So I'm going to write 1 over, and normally I'd write 1 over x, but inside I have 1/2 x plus 1. Outside, I still have the -4. And early on, graphing things from the explicit equation is a little bit more difficult. Okay? Could you recognize that the parent function was 1 over x given this? I think so, because there's like a fraction with the x on the bottom. Okay? But then you would have to recognize that this is inside the function as a horizontal stretch. Here is your horizontal translation. Here is your vertical translation. The function notation, I think, is easier to see the transformations. It's a little bit more complicated in the equations.
Would you get one on the top? Would you get one on the top?
Where the one on the top is from the original function. The original function was 1 over x. So anytime I had this green box, f of something, since f of x means 1 over x, this means 1 over whatever's on the inside. And then I have the minus 4 outside. The minus 4 is still outside and after as well. But it's good to recognize how to go back and forth between function notation and explicit notation. Okay, questions for practice on this one? 7 and 11. Yes. Oh, it didn't. I needed to reread the question. I was so far from the beginning of the question. Oh. And of each one, of course they want each one. So domain of the red one, the easiest way to write it is just write what's not allowed. X can't equal 0. And the range, same thing, of the original, y can't equal 0. Then on our blue one, our domain is now x can't equal minus 1, and our range is y can't equal negative 4. For those of you that like other notations, I'll just do the 1. If it can't equal negative 4, in interval notation, you would start at negative infinity. You would include everything up until you got to negative 4, but negative 4 is not allowed. So you'd have a round bracket. Then you would jump over negative 4 to the other side of negative 4 without it included, and keep going all the way to infinity. When we have 2 intervals, we put a big U in between them to say it could be here or here.